All right, welcome back from break. I'm Matt Taylor from Raytheon Technologies. With me is Ralph and Sean. We'll give you an introduction to us in just a moment, but we're offering here today a perspective on federal weather and climate resilience, something that we think we have a little bit of a unique view on, and a little bit of a unique view for this conference to look more at the federal acquisitions and the federal spending in this space. Weather and climate resilience, we picked resilience specifically here. There's a lot of nouns out there that could describe what the focus is of our community, of the world around dealing with the effects of a changing environment. Resilience is one way that we're looking at it forwardly and how we respond, how we mitigate the effects of this, and what we do to change the culture, change our behavior to be more resilient to these changes. I'm Matt again. I fall in the business development world. This is the conventional term for which we've renamed requirements and capabilities to be more expressive of understanding the needs of our customers, our clients, and the capabilities that they desire. If I could spell capabilities correctly, of course. It's working here in this portfolio called Environmental Intelligence and Civil Space, an element of our Raytheon Intelligence and Space business. And big Raytheon, we're a conglomeration of this business unit, Raytheon Intelligence and Space, Raytheon Missiles and Defense, does very much as their name sounds. Collins Aerospace. This is a group of companies that have come together under that name that include quite familiar aerospace companies like ARINC, Rosemont Aerospace, one of the inventors of the pitot tube, Goodrich, a number of aerospace folks in there, and Pratt & Whitney. So if you fly commercial, chances are you've flown on their engines. These are major companies in this larger aerospace and defense community that have come together to become Raytheon and Raytheon Technologies. In our environmental intelligence and civil space world, we operate in a portfolio that looks at NOAA, NASA, and then DoD environmental, forecasting, weather, prediction concerns. And it's kind of a unique perspective seeing all this across the federal government. So inside of NOAA, we look at the Advanced Weather Interactive Processing System, AWIPS. That's the forecaster workstation out there at the weather forecast officers and offices in the river forecast centers and then the national centers in the Weather Service. We look at the JPSS, Joint Polar Satellite System program, and the operations of that system. We fly the satellites, we process the data off of it. Over in NASA, we work with their large environmental satellite store inside the EOSTIS Evolution and Development Program. And we have presences out in Omaha with the 557th Weather Wing on the Air Force and Jet Propulsion Lab for NASA out in Pasadena, and a number of other locations with interests across this space. So we're deep in expertise here and wide in the community. There's another contract on here called Earth Prediction Innovation Center, EPIC, that with NOAA and OAR we'll talk about a little bit more specific in a following slide. Until then, let me let you be introduced to Ralph and Sean. Ralph?
Sure. Appreciate the opportunity of being here. As you see by the slide, I'm a senior solutions architect. I've been an operational meteorologist for 40 years, all of that in the Department of Defense. My last job, I was the director of weather for the Air Force and the Army. My focus here at Raytheon is to work a variety of programs which will enhance the national capability from a weather forecasting, climate change, and applications. So it's a great place to be. The company's involved in lots of different things, providing innovating solutions to solve tomorrow's problems.
Hi, everybody. I'm Sean Miller. I am the technical director in the organization that Matt was talking about. I've been with the company for almost 25 years, working across all different aspects of support to the weather, water, and climate enterprise, with most recent focus on capabilities and technology and how we can bring those in to better solve our customers' and missions problems, whether that's programs that we have today or whether it's things that we want to bring in the future. So excited to be a part of this, and I appreciate the opportunity to talk.
In this federal space, there's one principal motivator in a lot of the companies like us, our involvement, our investments, and it's really the country's budgets. So we do overlay our vision, our architectures for how we see these systems evolving. We do try to communicate this message out to the senior leaders out in the congressional side, in the hope that those visions have tackiness, effectiveness for how they develop their budgets. But ultimately, the government goes where the government does. And these drive how we think about how we respond, how we work day to day with the government. So we're seeing major investments in this weather and climate community. I'm highlighting here the NOAA Blue Book. This is the proverbial year-over-year Bible with its companion text, the congressional justification in NOAA. And many of these agencies, NASA has their congressional justifications as well. DoD has a little bit of the same form, but it's significant when you look at a $5 billion plus or minus agency taking a $1.4 billion increase in their budget. It speaks to the administration's investment into this area, the understanding of the impact of these events, be it severe weather or more persistent climate change. And it doesn't take much more than looking at the cover of this Blue Book for this year to understand the things that are most effectual in this space: flooding, wildfires, making a nod to the impacts of space and solar weather on the technology and the advancement of technology, and hurricanes, of course. So there's companion legislation that we're paying attention to. There's major investments in weather and climate resiliency in the IIJA this year. You might say, does this all go into the hands of a major contractor like Raytheon? And no, and very much not so. These dollars are distributed in many ways down into smaller increments, especially in NOAA, and out into grant opportunities in other civil agencies that increase awareness and education. This is not just for traditional U.S. concerns, but out into native lands. So the administration's making strong investments, not into core technologies, not just into large businesses, but down into small businesses and out into underserved communities that need to better understand and react to this changing environment. And bearing with a little bit of a blurry graphic that I cut down here to take in the colors as much as any particular detail of it for the slide. NOAA envisioned in their challenge to better understand the environment a system that helps improve the accuracy of their models, and acknowledging along the way that it's a really difficult system. Weather modeling is a really difficult system to understand, to spin up, to work with as an academic, as a researcher, and that there needed to be a community center for folks to work with, common development tools, common data sets, promotion of reproducibility of results, not taking in a much longer journal cycle, these results and trying to implement them inside of a traditional government institution. This brought about the Earth Prediction Innovation Center that Raytheon was fortunate to make a prime proposal against and was awarded back in June of 2020. We're working today with Tomorrow IO as a key subcontractor, as a key contributor on this to take this unified forecasting system, which off on that left side of the cut graphic, you would see all the little modules work through this vision for EPIC and having all the tools and capabilities the researcher and academic government software programmer may need to produce an operationally transitionable piece of technology enabler in those weather model suites that fall off onto the right-hand side as part of that unified forecast system. An investment in and of itself, not an investment in a single piece of technology, but an investment in a methodology to increase the effectiveness of the research community. R2O is a major part of climate resilience. The following slides, the remainder of the session, take a view from Ralph and Sean. That means I get to be quiet, of real perspective on the street, a change in course of this community, what has happened since their careers started with technology, with the focus on climate resilience. So these questions look at a perspective, one that you might share from your experience, but one that's uniquely had here in Ralph and Sean. So the questions on the screen for you, I won't repeat it. Ralph, I called on you first for introduction, so I'll let Sean have a go here at this.
All right, thanks, Matt. So thinking first about climate, when I first started tracking that discussion professionally, a lot of the debate and attention of the models was centered around, is it really happening and how much of it is human induced, with kind of then a subsequent eye on what might the impacts be. Now, X number of decades later, it seems like we're sort of seeing the reality of what the impacts are. And so the shift in the models and therefore the technology needs are moving away from just, is it happening, to what are, we see impacts, how do we have to adjust our models to reflect that new understanding of how it all works, but also what are impacts of adaptation and mitigation strategies that we can take, and how does that interact back with the models? So I think it's a little more complicated now in terms of taking that extra step from, modeling temperature increases and things like that to, what is really happening. That then ties in, I think, to the answer on severe weather, which we're seeing more severe events, most likely as a consequence of climate change. And so algorithms that used to work for those situations probably need to be more, not just be updated, but be able to be updated continuously over time as things continue to evolve. And that includes the newer machine learning models and, trying to avoid things like drift in the models as the world around us continues to change. So I think the technology for translating all the observations we have into predictions has to evolve as well, based on those kinds of changes.
So from my perspective, obviously having been in the applications business in DoD, we've really changed our focus when it comes to climate resilience and severe weather technologies. I mean, 40 years ago, climate was considered as part of the planning process. So if you're going to deploy or operate in some part of the world, what's the standard climatology? Are we appropriately prepared to move into that part of the country or the world to conduct some sort of operational capability? As climate has changed and it's impacting our infrastructure, we've taken a new look across that. And the focus has become, is our current infrastructure good enough to survive climate change? What does it mean to building construction? How are our ports? How are changes being impacted to aviation? Can tanks still arrive in time? I mean, it's all about the application. How is climate resilience? How are we going to deal with that? There's potentially lots and lots of infrastructure changes coming due, because if you built a base or a deployed location in one way because of weather, that's to be expected there. And now that weather has changed, i.e. more severe, wetter, drier, higher floodplains, all that focuses. So that's been the biggest change, that climate is becoming a reality in day-to-day planning and operations. And of course, from a severe weather technologies perspective, if you think about it, when I started forecasting 40 years ago, tornadoes and severe weather is something that we talked about happening in Tornado Alley here in the continental United States. Technically, tornadoes and severe weather could have happened anywhere in the world, but for the most part, they happen in the continental United States. Now tornadoes happen in Northern Europe, they happen in Italy, they happen all over the place. And so, as Sean already mentioned, a lot of the techniques and procedures that we have that work very well in the center part of the United States don't necessarily work that well elsewhere. So we need to come up with new algorithms, new techniques to account for increasing severe weather in all different parts of the globe. And I think the final comment, which is a big change, is from a climate resilience perspective, we are seeing the potential of more humanitarian crises down the road. Take an example, if sea levels rise, there's all kinds of island nations in the Pacific that could be impacted. As nations run out of water, for example, the potential is higher for conflict. So you're going to see a greater focus on climate resilience from a lot of the agencies in the federal government, because the potential for crises and conflict because of climate across the globe, from my perspective, could increase significantly in the next decades.
Thanks. And two more sets of questions here, gentlemen. We'll look for some speed round responses as we walk into those. I'll give yourself and the audience a quick moment to read over here, and then ask Ralph that you jump in for the speed rounds response. Really take a moment here and for everyone, understand how ubiquitous weather is in your life. You pick up your phone, look at the app, but how embedded that might be in your consumer experience and your commercial experience. In the federal space, we may not be in that kind of integration sense, but the technology is there. So, Ralph?
So this is a really big deal. This is something I'm very excited about. I think most of you know that over the last couple of decades, we continue to improve our models. Models resolution goes higher and higher all the time. When I started 40 years ago, our model was a 60-kilometer grid. Today, we can run models much less than that. I know that Tomorrow IO runs models down to the 10-meter point. National Weather Service runs it down to 1 kilometer. So higher resolution models are going. But the thing that's been missing, if you run a higher resolution model, you need a lot more data to make it successful. And I think the key technology are the LEO constellations that are providing lots and lots of data for environmental monitoring. I know that Tomorrow IO is going to launch its own constellation here very soon. There are a variety of other providers out there, but by incorporating, new microwave sensors, GPS RO data, radar sats, and so forth, we can really increase the sampling that we need to support all these higher resolution models. And I think that's going to improve our initial conditions, which is going to allow us to produce more accurate models. And then you can really integrate that data into the decision systems. And of course, the other thing that goes along with that, because of machine learning and machine-to-machine transfer, it's going to be an effective way to take the higher resolution data that's more accurate and then turn the probability forecasts into something that machines can understand. I know that for most of us, when I tell you there's a 65% chance of rain, that doesn't always translate into something useful, but the machine really understands what that means and how it applies. So I think the combination of more data, high resolution models, and understanding of probability forecasts from a machine learning perspective is the key to the future.
Well, Ralph, you couldn't have teed up my response here any better. I completely agree with everything you just said, and also think that another key technology is the data management piece. Starting with smart search capability to be able to look and find data that may be anywhere in a growing number of databases and archives out there, to the kind of connectivity that you need to be able to get access to that data, which includes, whatever the user or application is, has a common sort of front end to it. But in the back end, you've got to be able to interface with all these different places where the data come from. And then finally, once the data are available to an application or to a user, how do you accelerate it into a state that it's ready to be used, whether that's ready to be used by a machine learning algorithm, either for training or for production, or whether it's a more traditional algorithm that needs to fuse that data with some other data set in order to help accelerate to the decision part of the whole situation. So I think you can kind of see it's an integrated across the enterprise set of technologies that are needed. And obviously, as Ralph started with, the data are kind of at the center of all of it.
Kind of following on to that same theme, when you think about the change in technology, you also have to acknowledge the Teslas out in the street, that the rise of autonomy is significant in this community. When you start thinking about this, what airline could ever have operated without a good weather forecast? Could they have only flown in clear weather and still had a business? I think the simple answer and the obvious answer is no, that you've got to fly in the margins. You've got to fly in rough and uncomfortable weather at times to make the business close. And autonomy and drones, a lot of that I think we've seen has been in clear weather, in good circumstances and best conditions. Whereas the real world, the real atmosphere is much more tumultuous in its effect. That's just one part of autonomy. But let me turn it back over to you, Sean. Where do you see the biggest challenges in weather decisioning in autonomy and integration and the automation here that go into making autonomy work in a real world?
Well, I think probably one of the biggest challenges with autonomy, and that naturally translates these days into machine learning and associated other types of AI, is trust. There are folks that have been operating in these decision-making environments for a long time that are going to be slow to want to adopt something that's taking on some of the decision-making process. And to me, it's always going to be a case of the human makes a decision. I think we're a very long way away from the machine being able to do that, but how can the machine best assist the human? And so I've seen a lot of focus recently on explainable AI and trusted AI and equitable AI and all of those things that will truly make it more like the decision maker, the forecaster, whoever that might be. It's almost like they have a trusted advisor instead of just a machine. And any technologies, I think that's going to come. I think there's a lot of focus on it in the community, so I think there will be solutions that will continue to arise there. But ultimately, that end goal is kind of where I see it. And the side benefit of that would be, we see this turnover in staffing all over the place, just about every domain you can imagine, and weather is not immune to that. If you've got that kind of consistent sort of advisory capability in the background, that kind of helps to soften the blow when you have to transition from from one person to another. So that's kind of where I see the focus needs to be.
So this is a very broad question, and frankly, so Raytheon has been doing a lot of work in this area, and let me get down to what I would call the crux issue, and Sean already alluded to it. I mean, today we have weather forecasters, but the weather forecasters we don't account for are the human beings that are flying airplanes, controlling drones, or driving cars. The bottom line is all of them are forecasters as well, because they look at the weather and then decide what the weather is going to do to the mission that they're currently conducting. In autonomy, those people aren't going to be there anymore. They're not going to be making those decisions. We need to find a new way of replacing those people. And I think that's the big challenge ahead. If you think about it, just looking at aviation real quick, we have lots of weather sensors out there. And for many of us, we think it's a significant amount. But the reality check is only 3% of the continental United States is covered by weather sensors. 3%. That's not a whole lot. So all those human beings are having to cover the gap that's currently out there. And part of the challenge comes down to the regulatory guidance that we currently have. A lot of us are using models or remote sense data to cover the gap, but the bottom line is certainly in the airplane business, that data is considered situational awareness data, which means it's not good enough to make automatic decisions. So we need to increase the amount of data that we have, either through more sensors, more algorithms, or potentially changing regulatory guidance to allow remote sensing techniques. That's a key step. And then we need to figure out how are these decisions going to be made. I personally think in the future, and it's going to be a long-term future, we're going to have algorithms in cars, in airplanes, in drones that actually sense the weather and then make decisions on board. And then we're also going to have a significant communications capability to interchange all this data. And this is where 5G plays a big role, because if you have 5G equipped cars and drones and they can exchange all that weather information, that'll allow for quicker decisions to be made. And of course, as we had in the previous answer, that also requires very strict data management techniques. There needs to be a big data lake where all this data is available and needs to be processed and then rapidly provided to the end users. So there's some pretty massive changes that are going to have to be made in order for us to replace the human pilots or the human operators that are out there today.
Thanks, Ralph. I'm hearing how do these autonomous systems take into account the discretion we have as humans, a really tough problem, and then the communications underpinning all these things interoperating together, notwithstanding the need for increased observation of our environment to better understand it. Sean, that was a great point about how do you manage in a very fluid workforce the continuity in these positions, particularly in very weather sensitive operations areas. Maybe this autonomy gives us the opportunity to help improve that continuity between those positions. So it's a good point for us to wrap up on. We appreciate the time and attention here as we think about weather and climate resilience in the federal space. A couple years back, a major space launch company, I heard a quote that resonates with me pretty consistently, personally and professionally, that the long-term vision here on Earth may very well be having the Earth as a national park and moving all our industry, factories, resource mining, et cetera, into space. So, how we view ourselves, our existence here is largely going to be influenced by how we treat this environment, how we express our concern for the environment to our federal government, and ultimately how that federal government goes and acquires capability to make us more resilient, to change the vision for our life here on Earth and for humanity going forward. So thank you. Have a great rest of the session, and bye.